All right, so based on what you all showed me in class, we need to practice moving things from one side of the equal sign. Here's the equal sign to the other. In this case, it actually says we want to move everything to the left side. The reason why is because we want to keep that x squared positive. So from algebra 1, right, if there's no symbol in front of the 7x, there's an imaginary plus. So to move something over to the other side, you do the opposite, which is minus 7x. So minus 7x, okay? So now we're going to have 3x squared. Let me move this over here. So we're going to have 3x squared minus 7x. This cancels out, is equal to negative 4, and we want to move all terms. So we want to move that negative 4 over by also adding 4, so plus 4. Okay. So when you do that, you're going to get your final answer, which is 3x squared minus 7x minus, no, sorry, plus 4 is equal to 0, and that is going to be our trinomial. All right. So this is a review of what we did last time. So we're going to get this weird thing, which is the radical square root by itself. What's holding the 4 with this radical together? That is an imaginary times sign. If there's no symbol, that's like if you had like 5x, there's an imaginary times sign holding that together. So we want to break times, do the opposite of times, which is division. Divide both sides by 4, cancels out. So we're left with square root of 2x plus 5, and it actually does say solve, so we're going to go ahead and figure out what this is. So we're going to do 52 divided by 4, and that gives us 13, okay? So we get equals 13. So reminding you from what we did last time in class, we want to take this square root and get rid of it. So how do you get rid of, or the opposite of square root is to square both sides. We're going to square. So that allows us to cancel these out. And so you're left with 2x plus 5 is equal to 13 squared. 13 times 13 is 169. And we've got to get the x by itself, minus 5 from both sides, minus 5 from both sides, and you get 2x is equal to 164. Divide by 2, again, because that's multiplication, so we want to get rid of it. So we do 164 divided by 2, 64 divided by 2, hit enter, and that gives us 82. Okay, so now to check it, we went through this in class. I just want to make sure that you are good with this. So to check it, we're going to go back to the original. So this is our original question, our original problem. And we're going to type that under y1. So this is going to be under y1, and whatever's on the right is going to be under y2. And I want to show you something. So we're going to go to y equals here, type in 4. Radical is second x squared. So we're going to do 2x plus 5, and then we're going to go to y2 and type in 52. So if I just hit RAF, I already know that one of them looks like it's going to show. That's our blue one, which is the first one. But the reason why y equals 52 doesn't show is because that's all the way up here. It's all the way up to the top. So we're going to hit window, and let's go to our y max here. And instead of 10, let's change it to a number bigger than 52. Let's just say I do 70, okay, just to make sure that I can see it. And now you should be able to see, okay, there's the first one, which is the 4 square root 2x plus 5, and then there's the 52. We don't see where they meet yet, okay? So now we're going to change our window. We're going to go to the right. So I'm going to go to the x max, and let's go ahead. I already know my answer is going to be 82, so just to be safe, let's go ahead and put 100. If you didn't know that, you could play around with your window a little bit to see if you can get that to work, and there we go, right there. Okay, so that looks like it's about 80 something. Let's go ahead and prove it, right? So you get the calculator to find out that point of intersection by doing second trace. Option number 5 is intersect, so we're going to hit number 5. You can take your mouse and move it closer since there's only one point of intersection. We want to try to get somewhere in that spot right there where they meet, right, where the red and blue lines meet, and we're going to hit enter, 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 and it'll give us, boom, x equals 82 right there. Okay, we don't care what our y is, we know x is equal to 82, so therefore our answer is correct. We're done. All right, the next one says simplify, so we're going to take this and simplify it. And when we simplify it, that's just figuring out two numbers that multiply to give us 63. So 9, right? 9 goes into 63. We can go ahead and check that. by doing 63 divided by 9. And if you didn't know that 9 goes into 63, what you could do is you can go to your y equals, you can go ahead and clear what's there, and do this. Do whatever this number is under the radical, take that and do divided by x, and this gives you all the numbers that multiply to give you 63. So 1 and 63 is 63, right? But that doesn't help me because we still have to break down the 63. 3 and 21 is also 63. 7 and 9, right? We're ignoring these decimals. We're just looking for whole numbers. 7 and 9 give us 63. 9 and 7 give us 63. And if you scroll down, you'll get 63 and 1, okay? As well as 21 and 3. Anyway, moving on. So 21 and 3, you could use that, but the square root of 21 is not a whole number. So I'm just going to go ahead and use 9 and 7. And the reason why is because the square root of 9 is just straight up 3, right? Because 3 times 3 is 9, or 3 squared is 9. So square root of 9 is 3, so that way we're done. And square root of 7 is just square root of 7. So what is your answer? Your answer is 3 square root of 7. Done. If you did the square root of 21, you would get the same answer, except it would take you longer. And you could go ahead and do that and try it. All right. We're going to go ahead and do this part right here in class. So for right now, we would have done it already. So what are the imaginary solutions? Okay, so this here is, we have a trinomial 1, 2, 3. They're giving us a formula here. This is called the quadratic formula. First thing you want to do is figure out, in front of the x squared, there's a 2, so a is equal to 2. In front of the x, there is a, do you see the negative with the 3? So b is equal to negative 3. And the number that's chilling by itself is our c, so c equals 9. Okay. You might have touched on this in Algebra 1. It's been a long time, so that's why we're going to go ahead and do this. So now, let's go ahead and plug that into the formula. This formula is something that will be given to you on the Regents, so you don't need to memorize it, but it's good practice. So this says whatever b is, you're going to do the opposite of it. So b is negative 3, so the opposite of negative 3 is plus 3. Then you put a plus or a minus sign next to it, okay? Then you put a square root always, and then you're going to take b and square it. So our b is negative 3. You see I put it in parentheses because it's a negative sign, and we're going to square it because that's what the formula tells us. Then we're going to put a minus sign. 4 always comes next. You're going to put whatever the a is and whatever the c is, okay? So our a is 2 and our c is 9, okay? Again, if I'm going too fast, you should be pausing the video, taking notes. If you have a question, pause the video and ask, okay? And on the bottom is 2a. What is a? A is 2, all right? So now our calculator pretty much does a lot of stuff for us next. So what we're going to do is whatever's under the radical, under the square root, inside the house, you're going to take that and you're going to plug it in exactly as is. So parentheses, negative 3, close parentheses, squared. Notice I did not plug in the radical. Minus 4 times 2 times 9. There were no negatives, so I didn't need to put any other parentheses, and I'm going to hit enter, and I get negative 63, okay? So we have here, going back to this here is 3, so 3 plus or minus square root of negative 63 divided by 2 times 2 is 4, all right? So it says, what are the imaginary solutions? We would have gotten up here and done a little bit of discussion about what imaginary numbers are. So the square root of negative 1 is, you should know that this is the same thing as I right now. So square root of negative 1 is considered an imaginary number, and it is specifically imaginary. It's a imaginary, which is the I. Okay, so over here. So now it says identify this and substitute, which we did, express the solution in a plus or minus bi form. So all that means that we're going to take this and we're going to split it up. Okay, so let me just go ahead and change colors here so you might be able to see it better. Let's pick bright orange. All right. So here we have 3 over 4. and you can't simplify that if you tried. So 3 over 4 plus or minus, right? Because that's what separates it. And then we have here, we have the square root of negative 63 over 4, okay? Because it says write it in imaginary form, we're done. However, you should be able to simplify that square root of negative 63. And there are a couple of things that happen when you try to simplify this. The first thing is, because there's a negative sign under the radical, an I is going to come out, okay? What numbers multiply to give us 63? We kind of already talked about it. Square root of 9 and square root of 7. So the square root of 9 is equal to 3. And so we're going to go ahead and say, okay, this is simplifies to 3 over 4 plus or minus, right? On the top, there's a 3 here, so we have 3. We usually put the I next, so 3I, and then the radical next. So 3I radical 7, and this is all over 4, okay? This right here is our answer. So that was a lot, okay? I get that it was a lot, but it was just this part right here, the calculator gave us this negative 63, and then we simplified, all right? And so now we're done, and we've answered it in A plus BI form. All right. This one right here, use the TI-84, which is our calculator, to determine if the solutions are imaginary. So all we have to do is see if this is imaginary, and I'm going to show you how to do that. So we're going to go ahead and type in x squared minus 5x plus 13, okay, and we're going to see what that graph looks like. All right, so my windows are still adjusted from last time. Let's just say it wasn't. If I hit zoom and option 6, which is standard, I'm going to see something that looks like this, okay? So here's my x-axis. Does this blue graph ever cross the x-axis? And the answer is no, it does not, right? So it says determine if the solutions are imaginary. That means, right, if it doesn't cross the x-axis, the solutions are imaginary. That is true. So let's go ahead, as good practice, let's just go ahead and just draw this real quick. So our graph looks something like that. And we could say state if the solutions are imaginary or not. Does not cross or touch the x-axis, and it doesn't. So the solutions, so we just write the solutions are imaginary. All right, good, done. Go ahead and do the checks for understanding right here. Remember to use the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So go ahead and do this question, show Varghese, and then go ahead and do the delta math as well as these level 1 questions. All right, good job.